Alright, so we're going to go over our notes for rational versus irrational numbers. First thing we need to know is our vocabulary. So rational numbers are numbers that can be written as a fraction. That includes our natural numbers, which is your counting numbers, your whole numbers, which is your natural numbers including 0, your integers, which is your positive and negative numbers. You have decimals, you have terminating decimals, which are decimals that end, and you have repeating decimals, which are decimals that have a pattern. You have fractions, you have mixed numbers, and you have perfect squares. And remember, your perfect squares is like the square root of 4 because 2 times 2 is 4. So all of these different types of numbers are rational. Natural numbers, whole numbers, integers, terminating decimals, repeating decimals, fractions, mixed numbers, and perfect squares. Next we have irrational numbers. And irrational numbers are just the opposite of rational numbers. These are numbers that can't be written as a fraction. And the list for this is a lot smaller. We have our non-perfect squares, which, remember, if we take the square root of a number, it's not going to be a whole number. And then we have never-ending and non-repeating. So that means it never ends and there's no pattern. Decimals. Alright. So I'm going to write a few numbers down and we are going to determine if they are rational or irrational. Alright, the first one we have is pi. Pi is irrational. I'm just going to put an I for irrational and an R for rational next to them. So pi is the most common irrational number because it never, ever, ever, ever ends. We use it in math to solve different equations, and we round it and estimate it to be 3.14 because you can't use a number that never ever ends in math. Alright, let's look at the number 18. 18 is a whole number or a natural number. So that's going to be rational. If we use -8, that's also rational because that's an integer. 3.4. This is a terminating decimal because it ends. A terminating decimal ends. And a terminating decimal is rational. 3/4. 3/4 is a fraction. And remember, the definition of a rational number is a number that can be written as a fraction. So 3/4 is rational. 0. Sometimes 0 is a little tricky for some. 0 is a whole number. So that is rational. The square root of 9. The square root of 9, we need to determine if this is a perfect square or a non-perfect square. So we made our perfect squares and our perfect cubes chart. And anything on that perfect squares and perfect cubes chart are rational numbers. if we look at our perfect squares and perfect cube chart, we can see that the square root of 9 is 3 because 3 times 3 is 9. So that makes this number rational because the square root of 9 is a whole number. One thing we forgot to add to this list is perfect cubes. Alright, let's see. If I have the square root of 144, again, we need to look at our perfect squares chart. If our square root of 144 is a whole number, then it's going to be rational. And the square root of 144 is 12 because 12 times 12 is 144. So we get a rational number. If we want to do the square root of 16, there's not two numbers that multiply by itself to give me 16. Meaning there's not 1 times 1 or 2 times 2 or 3 times 3. I'm sorry, there is 4 times 4. I'm sorry. 4 times 4 is 16, so again, that's rational. I was not thinking straight. Let's say we have the square root of 3. This does not have a number multiplied by itself to give me 3. So this one's going to be irrational. If I have 0.76 with the bar over it, remember, that means that bar over the 7 and the 6 mean that the 7 and the 6 are repeating. And remember, repeating decimals are rational. If I do the cubed root of 8, you need to look at your cubed root chart to determine if the cube root of 8 is rational and irrational. That means you need to determine a number multiplied by itself 3 times. Is there one that gives you 8? And there is, because 2 times 2 times 2 is 8. So this is rational because the cubed root of 8 is 2. Now 3.14. This is one where a lot of kids make mistakes. 3.14 is rational because it is a terminating decimal. This decimal ends. It's an estimation of pi, but it's not, 3.14 is not irrational because it's a decimal that ends. I'm going to do one more example. If I do the cubed root of 10, we need to determine if there are 3 numbers that multiply by itself to give me 10. You can also look at your cubed root chart that we made the other day in class. And the cube root of 10 is irrational because it does not give us a whole number as our answer. So again, remember that a rational number is a number that can be written as a fraction. That includes natural numbers, whole numbers, integers, terminating decimals, repeating decimals, fractions, mixed numbers, perfect squares, and perfect cubes. Irrational numbers are numbers that can't be written as a fraction. These are non-perfect squares and never-ending and non-repeating decimals. I guess we can put non-perfect cubes too.